Hello Ninja Warriors. So today's session is all about permutations and combination. Basics of permutation and combination is already covered in part number 1. So this session is going to be about part 2. What we are going to cover in this session, let me tell you. So we will start with circular permutation. Okay, circular permutation will start. Then next, we will move towards some problems wherein you have to arrange distinct objects, you have to arrange alike objects, right? So this is gonna be the second topic. Third will be dearrangement. Yes, dearrangement. Okay. And we'll end the session with the fourth part, which is Beggar's method. So today's session is going to be very, very important, and I will highly recommend that if you have not watched permutation and combination session number 1, do watch it before this session. Why? Because if you build the concepts nicely, then you will understand all these topics better. To have a better understanding of part 2 of permutation and combination, go and watch part number 1. Okay. All right. So let's begin. Let's quickly begin with circular permutation. Right. So this is actually one of my favorite topics, most favorite topics, I will say. Okay. All right. So circular permutation. So yes, let me just go straight away towards circular permutation. Where is circular permutation? All right. So this much we already have completed, right? Okay, yes. And also I forgot formation of groups. How can I forget that? Formation of groups also we are going to cover. Okay. So let's start with circular permutation. So unlike the linear permutation, circular permutation of n distinct objects can be done by n minus 1 factorial. What does that mean? So suppose you have to arrange 4 students linearly in a row, and you have to arrange same four students, but this time in a circular manner. Okay, maybe on a round table, or you just have to make them stand in a circular fashion. So 4 students permutation, all know, is 4 factorial, right? So person 1, person 2, person 3, person 4. The shuffling will happen. The arrangement, that means shuffling will happen. So that can be done in 4 factorial ways. But here in circular fashion, P1, P2, P3 and P4. है ना? Okay, so 4 students are there. So as per the formula, that can be arranged by 3 factorial ways. That is 4 minus 1 factorial. Okay, so there are 24 ways to arrange 4 students in a linear fashion, but there are 6 ways to arrange 4 students in a circular fashion. Okay, now let us solve some problems on this and get our concepts crystal clear with this example. This is a perfect example wherein you can clear your all the things, all the concepts very clearly. Okay, so first, the number of ways in which 5 boys and 4 girls, that means total 9 students are there, right? So 9 students are there that can be arranged in a round table if there is no restriction. No restriction means you can consider this as a pool of 9 students. No boys, no girls, no restriction. So 9 students arrangement in a round table can be done by 9 minus 1 factorial. That is going to become 8 factorial. Right? Yes? Clear? Okay. Now second part. All the girls are together. Okay. So when all the girls are together. Now, do you remember we did something on this note when girls are together or 2 units are together? So remember, what is that? Tell me. Fevicol method. All right, Fevicol method. Okay, so Fevicol method says that whenever a few things have to be kept together, why not make it as one entity? Just glue them together. Okay, so here 5 boys and 4 girls. So clearly 5 boys, B1, B2, B3 and B4 and one more B5. But all the girls, I have glued them together, G1, G2, G3, G4. How many units are there, or how many objects, or how many students are there. So 5 the boys and 1, I will consider this as 1 unit. Okay, so 5 plus 1, 6, total 6 students are there. Now again you have to arrange in circular manner. So 6 ke liye you have 6 minus 1 factorial first of all. But even if they are together on a round table, understand, this is B1, this is B2, this is 3, 4, 5, and all the girls are 1, 2, 3, 4 here. But still they can arrange themselves, they can shuffle among themselves, right? So that can be done by 4 factorial. Okay, so this will be considered as a linear. This portion will be linear arrangement among themselves. So that's why 4 factorial. So this is going to become finally 5 factorial, 4 factorial. Second part. Done. Now, third, all the girls are not together. So here I'll be using principle of complement, because we know that total number of arrangements is 8 factorial, right? So this is going to be total minus when girls are together. Okay, so total is what? Tell me. Total is 8 factorial. Minus when girls are together is 5 factorial, 4 factorial. This is your third part. Okay. No two girls are together. Sorry. No two girls are together. Not kizar. There is no need for not. Hai na? No two girls are together. Now remember, whenever you understand this, no two girls are together, just go back and watch in part number 1. What we have understood, what we have studied is no two girls are together. That means gap method. Gap method says that whenever no two girls should be together, then leave these girls. Talk about boys. Give priority to boys. Make them sit in circular fashion. So there are 5 boys, right? Now 5 boys can be seated in how many ways? 5 minus 1, 4 factorial. So 4 factorial for boys, correct? Now 5 boys, you in 4 factorial, so 1, 2, 3, 4, 5 boys are there. Gap method. How many gaps are getting created? So in circular fashion, what happens is gaps are exactly same as number of students or number of objects. Okay, so even if you count, you will realize this is 1 gap, 2 gap, 3 gap, 4 gap, 5 gap. Hold on. Yeah, 5 gaps. Right. Perfect. 5 gaps. 5 students, 5 gaps in a circular fashion. But in linear, there will be 1 extra gap. So in gap method, what we did again, no two girls are together. So whenever we don't want to keep two same things together, what we do is we leave this thing and we go towards the boys. 4 factorial for boys. Okay. Because 5 boys, circular fashion, 4 factorial. Now, how many gaps are there? 5 gaps. So you want to make the girls sit in the gaps in such manner that no two girls are together. Now there are no chances, right? If you make them sit in a gap, that means like 2 girls will always have 1 boy in between. If 1 girl is sitting here, 1 girl is sitting here. Boy is in between. So this is taking care of this condition, right? So 5 gaps. How many girls? 4 girls. So now 5C4. So we have selected 4 gaps out of 5 gaps. Okay. So 1 gap is going to get wasted. Okay. 1 gap will waste. And that means 2 boys will sit together and 1, 2, 3, 4 girls will sit over here. So first of all, let's select the gap 5C4, and after that, suppose we have selected these 1, 2, 3, 4. So 4 places, 4 girls, 4 factorial. This is your answer. Okay. Yellow portion is for boys, this is for girls. Now you must be wondering, hold on ma'am, there is one doubt. We agree 5C4 and then 4 factorial. We agree 5C4, 4 factorial, correct? 5C4 to theek hai. But ma'am, why 4 factorial? Because 4 girls, so it should be 3 factorial because you are arranging in circular fashion. So first of all, let me just tell you, Once a circle is been set, na, then you never apply the second, like after that, do not apply that n minus 1 factorial rule again. So here, this is a clear-cut case of simple permutation for 4 places, 4 objects. Okay, because places are fixed right now. Understand? In the beginning, when we just arrange, so there is no such place fixed. That's why we have to do that 1 factorial less. But once n minus 1 factorial is used now, then after that you cannot use, because you have defined all the places. Now places are fixed. Now this is a clear-cut case of simple permutation. Okay, keep this in mind. All 4 options, I guess all 4 parts are clear. Let us move on and talk about some questions. Out of 10 people, 5 are to be selected around a round table. Okay, and the remaining to be seated in a row. All right. So what they are saying is we are having 10 people, 5 we need to send on round table, and rest 5 should be seated in a row. That is linear arrangement, right? So first of all, let us select 10C5. By 10C5, what I'm going to do is, I have selected 5 people for my round table. So now 5 people are there who has to be seated in round table. That can be done by 4 factorial. So this is the round table thing. Now remaining 5, or automatically there will be 5 left out students will be there. Remaining 5 to be seated in a row. So into 5 factorial, because in a row you just have to multiply with 5 factorial. Now you just open it, solve it, and you are done. So this is 10 factorial, 5 factorial, 5 factorial. Then we have 4 factorial, 5 factorial. Correct? So this is going to become 5, 5 cancel. And this is 10 factorial, 4 and 5, correct? So 10 factorial by 5. This is the answer. Yes, 10 factorial by 5. Okay. All right, clear. Now there are some things, some exceptions you can say we need to take care of. See, what is happening in round table? In round table, what is happening? You cannot flip the round table. Okay, you cannot flip the round table. Let me just give you an example. Okay, so but there are some circular arrangement where you can flip as well. For example, garland, necklace. Okay, so for example, garland, beads, necklace, right? These examples may you can flip it. Obviously, है ना? You can just, so suppose, let me just go through it. Let us take an example. You have a garland which is having 3 colors, red, okay, and green and blue. Okay. Okay, so obviously, 3, maybe 3 beads or 3 flowers. Okay, let's take flowers. 3 flowers in circular arrangement can be done by 2 factorial ways, right? That means 2 ways. So arrangement of these 3 things, arrangement of 3 color flowers in a circular manner can be arranged by 2 ways, right? So first one is this. Just let me know what is the second manner, what is the second fashion. So clearly, second will be, so can you see red, green and blue, correct? So second one will be, if red is here, no, then blue, and then we have green, correct? This is another type of arrangement. Only these 2 arrangement is possible, not a third arrangement is possible, है ना? This is just the order, red, blue, green, है ना? And then red, so red, green, blue and red, blue, green, है ना? Tell me if you can change, like if you can give me the third arrangement, third possibility. Not gonna happen, right? So this is red, green, blue, correct? This is first option, and this is red, blue, green. Please do not tell me that, ma'am, red can come here. Okay, if red is coming here and green is going here, then also it is red, green, blue. So red, green, blue is already taken. So understand, this is all about relative position. It is not about up, down and something like that. These are the movable entities. Okay, so अब you are saying that, okay ma'am, done, 2 ways to form a garland out of 3 different colors. No, Because what is happening, what I am saying is these two are same. These two are same. We are same, bro. We are same, bro. We are same, bro. We are same, bro. What does that mean, ma'am? Why are they different? Because if you notice that if I just pick this garland or necklace up and flip, if I flip, then what will happen? Just imagine. If I flip, then what will happen? So if you are going to flip, if you just, how to flip? Just pick this side and just flip it. If you are going to flip, then this blue color will be over here on the right. Just taking the mirror image, right? Flipping means mirror image. And red color will be here only on the top and green will be here. As it is, I am flipping. Just tell me, the moment you flip this particular scenario over here, don't you think that these two are same? Just by flipping. So what do you think? That if I flip the garland, shall it count as 1 or 2? No. So basically these two are same. This and this are exactly same. Right? So if I flip it, then it will happen. I hope that this is clear. Correct? So now what does that mean? What does that mean? That simply means that every situation will be counted twice. So we need to make it half. That is done by n minus 1 factorial by 2. So now you tell me, arrangement of 3 different colored flowers in a garland can be done by, so 3 at ma'am, 3 minus 1, 2 factorial by 2, that is one way. Only all these 3 are one way only, right? But you have to be very careful that in round table, flipping is not allowed. Now, you cannot just send students, ki, acha, okay, now you're sitting on gravity, now just go and sit on ceiling, right? You can't do that, okay? Because so there anti-clockwise and clockwise will counted as different, and here anti-clockwise. Can you see this is actually anti-clockwise and clockwise. So R blue green and R red blue green and red blue green. So these two are actually two different arrangement of a same thing. Just the difference is this is what? Clockwise and this is anti-clockwise. Okay. All right. I hope that it is clear now. Now let us start solving problem so that we get more clear idea. The number of ways in which a garland can be made by using 8 different flowers is 8 different flowers. So again, 7 factorial by 2 will be the answer. Easy peasy lemon squeezy now. Correct? Okay. Let us move on. How many necklace of 12 beads each can be made from 18 beads of various colors? Okay. So now 18 available are there. So 18, but we want only 12. So that means first of all selection will come into the picture. We will select 12 things out of 18 things. And 12 beads out of 18 beads. Now I'm having 12. Now 12, arrangement of 12 object in a circular fashion will be 11 factorial upon 2. 11 factorial upon 2. All right. Clear? Perfect. So this is your final answer. Formation of groups. Formation of groups. Okay. Now the next topic. Very important topic. Very, very important. Formation of groups. So what we will do over here is, so what is the problem statement? Let us understand first the problem statement. Suppose I have 5 different prizes. Okay. I have rewards. And rewards can be books also. So which book do you like? Tell me. You guys ask a lot of question on Cengage. Okay. So I have 5 different books of Cengage. That is calculus, algebra, trigonometry. Okay. 3 and then 2 remaining are from Tatva. Okay. So calculus, Cengage calculus, Cengage algebra, Cengage trigonometry, right? And then Tatva maths and Tatva physics. 5 books I am having, and I am having 3 different students. Okay, 3 different students. 3 different students. Are they looking different? Are they looking different? 3 different students are there. Okay. Now what I want to do is I want to distribute these 5 books among 3 students. Okay. So for that I will have to make a group, and also there can be a condition that like at least one prize, so I want to give to each one of them. Okay, at least one. So now formation of group will help me over here. So first of all, I need to think that okay, 5 I am having now. I can't do that 1 take it and then rest 2 I will think. No, that's not the way. Here formation of group will help me. So what I will do is, first of all, 3 people are there. So I will keep I cannot just like give the rewards like just like that. It will not look good. If I am a professional, I will call person A, person B, person C, and I will make the bundle that even if I am getting 4 books or 3 books to single person, I will make a bundle out of it. Bundle of 3, bundle of 2, and then bundle of 1. Like that. Okay. So first of all, I need to make sure that 5 objects I want to distribute in such a way that one student, maybe this one is my favorite student, I will give him 3 books. Then I will give him second one as 1 book, 1, and the third as 1. And can I do that? This is one way of doing it. So I need bundle. I need 3 bundles for 3 different people. Now, or I can do one more thing, that 5 books, I think 2 books and 2 books and 1 book. That's it. That's it. Then no more cases. Okay. So in that case, creation of bundle is formation of groups. Okay. Now, how will I do that? How will I do that? So first of all, what I will do is, out of 5 books, I need to select 3 books. 5C3. 5C3 say what we will do is, I will keep my 3 books aside. So let us say I have kept my 3 books aside and 2 I have rejected. Selected 3, rejected 2. Okay. So this is sorted. 1 bundle is created. 1 bundle is created. Book of 3. This is done. Okay. But now, out of these 2, can you see? Out of these 2, I need to again select 1 book. So that is 2C1. Okay. And now 1 is left out, rejected. That is again isolated. So that's it. We need to stop over here. Solve it. 5 factorial, 3 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial. So this is going to be 5 factorial upon 3 factorial, 1 factorial, 1 factorial. Okay. So what has just happened, understand. 5 factorial, 3 factorial, 1 factorial, 1 factorial. Just like this. Just like this. This is what has happened. Okay. So this is what has happened over here, that 5, 3, 1, 1. Right. So let me just tell you the direct formula of formation of groups. Formation of groups says that number of ways of dividing m plus n, that is total. Basically total, if I am having 10 and I am deciding that I will make 6 and 4 ka group, and 6 and 4 to 2 different bundles I want to form. 2 groups of 10 things. One is having 6 and another is having 4 objects. So total number of ways of dividing 6 plus 4 things into 2 unequal. So this is unequal groups of size 6 and 4, that can be done by 10 factorial upon 6 factorial, 4 factorial. By doing this, now I am having 2 different bundles. That's it. I have not distributed. Just I'm ready with like distribution. I am ready with these 2 bundles. Okay. All right. Chalo. Let us do some problems on this. है ना? Suppose this. है ना? Some concept building problems. Consider division of 10 things into groups in different cases. Okay. So 10 things I have to distribute. है So now groups, how many groups? So let us start with the very basic. If I have 10 things, let me think that in how many ways I can do that. So I can divide them into 3 groups. One is having 5, another is having 3, and this is having 2. So basically dividing 10 distinct things. This is division basically. Division, you can call it division, grouping or bundling. Okay. So dividing 10 things into 3 groups, wherein one group has 2 things, another has 3 things, another has 5 things. That can be done in 10 factorial upon 2 factorial, 3 factorial, 5 factorial. And understand these are unequal groups, right? Unequal groups ka this is the formula. I hope that this is clear. Okay. All right. ठीक है? Yes. चलो. Now what happens when, because ma'am you are focusing on unequal groups. What happens when the groups become equal? So let us understand what will happen when groups will become equal. Number of ways of dividing. Now this is again same thing. Number of ways of dividing. This is what we have done. 10 things in such a way that 10 things into 3 unequal groups such that 2, this is 3 and this is 5. So this is 10 factorial upon this is what we have already done. Right? So I hope that this is also clear. Very basic. So unequal ka this is the funda. Now let's get back to equal. है ना? Equal. So this is a general result that if there are like we have to divide in like k 3 groups, 4 groups also you can do. So you just have to divide by this much factorial. Okay. Chalo, abhi equal. Okay, equal. So suppose I am having 10 and I will divide this 10 into 2 equal groups, 5 and 5. है ना? So ideally how it should be? 10 factorial upon 5 factorial, 5 factorial. It should be there. But there is one more catch over here. In this particular thing, we have to divide by 2 factorial over here. But why, ma'am? And why 2 factorial? Because can you see number of equal groups? How many equal groups you are saying? Ma'am, 2 equal groups are saying. There is no 5, 5, 5. If 5, 5, 5 was there, then 3 factorial. So how many equal groups you can see? How many equal groups you can see? 2 equal groups. So that's why 2 factorial. So the formula says the number of ways of dividing 2n things into 2 equal groups. So 2n, n and n size each is 2n factorial, n factorial, n factorial, and this is again 2 factorial. Okay. Number of ways of dividing 3n things into 3 equal groups of size n each is. Okay. So that is again now 3n. So this is n, n, n. So that's why 3 factorial for that. Okay. Are you getting my point? Chalo. So now this we have already done. Na? 10 ka 2, 3, 5. Now what about this? So number of ways will be 10 factorial, 5 factorial, 5 factorial. But one more 2 factorial will be there. Because how many equal groups? 2 equal groups. Now you are like, now you know all the formulas. Now quickly, let's do some more exercises like this so that it gets on inside your brain. It settles down inside your brain. It gets into your muscle memory. Okay. So 10, 2, 4, 4. है ना? 10 को ही we need to think about multiple cases like that. So this also can be one case. So that can be done by 10 factorial upon 2 factorial, 4 factorial, 4 factorial. Correct? है ना? 10 factorial, 2 factorial, 4 factorial, 4 factorial, and this 2 factorial if you are seeing, this is because we are having 2 equal groups. 2 equal groups. That's why. Fourth point, okay. So again, now 10 ko we are dividing in such a way into 4 groups such that 3 groups are having 3 objects and 1 group is having 1 object, okay. So again, 10 factorial by 3 factorial, 3 factorial, 3 factorial, 1 factorial. And now 3, how many equal groups of 3? So that's why 3 factorial. Okay, all right, clear. If you're having any doubts, you can just right away drop a comment with the timestamp tagged. I will reply you within a few hours. Okay, chalo, now one more. 10 factorial by 2 factorial, 2 factorial, 2 factorial, 2 factorial, 2 factorial. Okay, but how many equal groups you are seeing, ma'am? 1, 2, 3, 4, 5. So one more 5 factorial se we have to divide. So 10 factorial by 2 factorial ki power 5 and this is 5 factorial. Okay, all right, clear. Now 10 things are there that can be divided in such a way that one group is having 4 and one is having 6. Again, this is so very simple. 10 factorial by 4 factorial, 6 factorial. Very easy. You know? So I guess this is also done. And the next. Now again, this is again not very difficult. This is 10 factorial by 1 factorial, 2 factorial, 3 factorial, 4 factorial. Right? Correct. And one more time. Oh, this is something. This will be 10 factorial. 2 factorial, 2 factorial. That means 2 factorial ka square. 3 factorial, 3 factorial. 3 factorial ka square. And. Now, how many equal groups are there of same size? How many groups are of same size? Ma'am, 2 groups and 2 groups. So that's why 2 factorial, 2 factorial. This is for equal groups of 2. This is for equal groups of 3. Hai na? So what will be your answer? 10 factorial by 2 factorial. Oh, this you can just ignore. This is the correct answer. Hai na? This is misprint, halfly print. Okay, all right, chalo. So this is, I guess we are done with the exercises now. Let's get back to the straight question. The number of ways in which a pack of 52 cards can be divided into 4 equal sets. Okay, can be divided into 4 equal sets. Acha. Pack of 52 cards can be divided into the 52. 13, 13, 13, 13. Obviously, all the 13 things should add up to 52. You can't do like that. 13, 1, 1, 1, 1. No, the addition of all 4 things should be 52. What will be the answer, ma'am? 52 factorial upon 13 factorial, 13 factorial, 13 factorial, 13 factorial 4 times. How many equal groups you are seeing? 4 factorial. Okay. So this is first ka answer. Okay. And now you have to distribute as well. Okay. So distribute. What is this doing? Understand what is this doing. So this is actually giving you, so you have 52 cards. And now what are you doing is, this thing is giving you in number of ways in which you can bundle 52 cards into 4 sets. So now you are having 4 sets. Set number 1 having 13 cards. Set number 2 also having 13 cards, different cards obviously. Set number 3 again 13. Set number 4 13. So 13, 13, 13, 13. Right? 13, 13, 13, 13. 4 bundles are available. Now 4 bundles are there. 4 people are there. Part number 2. 4 bundles are there. That can be done in this way. 4 people are there. So 4 things, 4 different things can be distributed to 4 different people, can be done in 4 factorial ways. So basically, same thing will be there. Okay, so division. 13 factorial power 4, 4 factorial. This is division, right? This is division. And now distribution. So this thing is division, division of groups. So this is division. And now distribution. Distribute karna, distribution. Okay, why I am writing this? Because 4 factorial to 4 factorial will get cancelled out anyway. Then you would be wondering what has just happened. So that's why writing is very important. This 4 factorial is done to know that this is the distribution. Okay, chalo, one more. Are we ready for it? Chalo. The number of ways in which 5 books can be tied up in 3 bundles. So first thing, is 5 books in 3 bundles. Now you have to think that how can I just tie them in 3 bundles. So suppose you are having 5 books, apply your brains. 5 books in 3 bundles. So what you can do is keep one bundle just like that having 1 book, second bundle having 1 book, and third bundle having 3 books. Okay. Or one more case also you can do. 5 books are there, one bundle is having 2, another bundle is having 2, and third bundle is having 1. These are the 2 cases. That's it. That's it. Right? Because if you say that, ma'am, okay, 0, you can keep one bundle as 0, but that won't be a bundle, no? If you for example, if you make it 0, 3, 2, 0. So that means actually what you're doing is, this is nothing. So you're making 2 bundles only. No, but they are clearly saying that 3 bundles they want, okay? So now, first of all, division. And in first part, they are only talking about division. Division means creating bundles, that's it. So division only. So that is 5 factorial, 3 factorial, 1 factorial, 1 factorial. Let's not forget equal group. So that's why 2 factorial plus 5 factorial, 2 factorial, 2 factorial, 3 factorial, 2 factorial. Okay. All right. So this is going to be 120 by 120 upon 3 to the 6 to the 12 plus 120 by 4 and 3 to the 6 to 24. So this is going to become 10 plus 5. So 150. 150 ways say you can distribute it. Okay. Now second part, now you have to distribute as well. And also they have written each student should get at least 1 book. So that we have already taken care of. Second one will be, so 150 will be the division thing. Now I have the 3 bundles with me. I have 3 persons with me. So I just have to just distribute by 3 factorial. So 150 into 6. So that is going to become 900. Okay. All righto. Clear? Chalo. All right. Now next. Now this is very different. Like we are done with formation of groups and division distribution done. Now another topic. Till now what we have covered, circular permutation and then formation of groups. Now we are entering in a different thing. In here, what we are going to do is, okay, let me just give you an example directly. Okay. So there are 10 lamps in a room. Each can be switched on independently. The number of ways in which room can be illuminated. Okay, very good question. So there are 10 lamps. Okay. So a lamp independently, can you see? They have written independently. So let us see. This is the lamp. This lamp is having 2 options, either on or off, correct? So like each lamp is having 2 options. Sorry. Lamp 1, lamp 2, lamp 3, lamp 4, lamp 5, lamp 6, 7, 8, 9 and 10. Okay. So individually I will treat it, each lamp will be treated as individually. This lamp, if I talk about this lamp, can be switched off or on, off or on or off, on or off. So this lamp has 2 options. This lamp is also having 2 options. This lamp is also having 2 options. So the last lamp will also have 2 options, either to switch off and switch on. So basically 2 raised to power 10 ways will be there, in wherein we can just handle all the lamps. Wherein there in 2 raised to power 10 ways, in this 2 raised to power 10, there will be one way wherein all the lamps are on, right? There will be a single way that I have switched on all the lamps. That will be counted as 1. There will be one way that 1, 2, 3, 4. These 4 are on and rest are off. These are the possibilities. Okay. There will be one way then where the first, third, fifth and 7th and 9th are off and rest are on. And there are multiple possibilities that is being taken care in this 2 raised to power 10. And there will be one such way as well where all the lamps are off. That I don't want, because the question says that room should be illuminated. What does that mean? Room should be illuminated means at least one lamp should be switched on. At least one lamp should be switched on. That means we do not want that case wherein all the lamps are off, and that will be a single case. So that's why we need to subtract 1, and this 1 is nothing but when all the ways, all the lamps are off. So this is the answer, 2 raised to power 10 minus 1. Okay. So this is a way of saying at least one lamp is burning or is switched on. Clear? Okay. Alright. So in this thing, let us just dive into this particular thing. And okay, so one more question I would like to say. One very popular question. So there are 8 true and false type of questions. Okay. True and false. Suppose I am taking a test and I'm like very chill. I'm saying, okay, only true and false. Nothing. So each answer is having only either true or false. In how many ways a student can answer attempt the paper? So one student will be all true, all 8 true. Another one more way will be all false, then T, F, as a random, so just like that. So all these things, if you want to calculate, so just understand there are 8 questions. Question number 1 has how many options? 2 options, either true or false. Question number 2, how many options? True or false. And same question number 8, true or false. So 2 raised to power 8 will be the all options, all ways wherein a student can solve a true and false type of 8 set of questions. Okay, same thing, right? Okay, so this is what it is. Now, yes, next. Now, this time, what we are doing is, we are talking about similar things. Similar things? Yes. We are talking about similar things in a manner like, for example, 5 oranges. 5 identical oranges, 5 identical balls. Okay. So now if I am having 5 identical balls, same color, same everything, identical. Okay, similar things. Now I want to select, select the total number of selections of, let's say, 5 balls, identical balls. 5 identical balls. Taken any number of things including nothing. Oh, what does that mean? Taken any number of things. That means if I want to have, suppose you are having 5 balls, 5 identical balls. Let's keep it that way. And I'm coming to you and I'm thinking that, okay, I want something. I want maybe all 5 balls. All 5. All 5 is one way of taking all 5 balls. Okay. Now I don't want all 5. I think you keep it 1, I'll keep 4. Okay. So all 4 balls if I am taking, so how many ways? Again, one way, because I don't have anything to choose. No. 5 identical things, taking 4 out of it. In how many ways I can take? One way. Take any 4. Everything is same. Take all 5, any 4, right? Any 3. Any 3 also one way again. Any 2 again one way. And any 1 again one way. And 0 balls. Suppose I am coming, because see, including nothing, and I am thinking, oh, let me just not take anything. That is also, taking nothing is also one way. So basically the number here, the number like the so how many? 1, 2, 3, 4, 5, 6 ways. So taking 5 identical balls. In how many ways? N plus 1 way. So here this number will matter. Number will matter. How many balls you are taking? Either 5, 4, 3, 2, 1. So taking n identical things out of, taking n identical things, selection of n identical things in any number including nothing will be n plus 1. And if somebody says, ki acha nahi, 5 identical balls, but I am coming to you, but I want at least one. I want at least one. I am not gonna settle down with 0 balls. You keep all the balls. I am not keeping any ball. What does that mean? So that means this way I am excluding. So in that case, 5 ways. That I am gonna tell you. And at least one thing. Now at least one thing. You have to pick at least one. So that means in how many ways? N ways you will have. Okay. So there are 3 similar letters such that AAA. So now what will you do? Total number of selections. है ना? तो no A, you are not taking any A. 1 A, single A you are taking, double A taking, 3 A taking. So 1, 2, 3, 4. So that's why 3 A to 4 ways. Okay. And if somebody tells you that at least one you have to take, so that is when you will say, okay, 3 ways. Fine. Okay, 3 ways. Okay, like that. Find the number of ways. Find the number of ways of selecting at least one fruit from 5 mangoes, 4 apples and 3 bananas. Now, again, identical, mangoes are identical, hai na? Of selecting at least one fruit. Acha, understand what is happening. So, what will happen is, taking mangoes, chalo, at least one ko please forget, because you cannot apply the condition of at least one in all 3. Because now we are having 3 different things, na? So, taking 5 mangoes in 6 ways, correct? 5 plus 1. I agree, that will include nothing also. 4 apples can be taken in 5 ways. And 3 bananas can be taken in 4 ways. So that is going to become 6 5s are 30, 120 ways. But ma'am, what about at least one? So 120 means now overall you have to subtract 1. So the answer will be 6, 5, 4 minus 1. So that is 119. 120 minus 1 will be 119. That's how you do these kind of problems. Okay, all right. Clear. Now one more thing, one more understanding. Suppose there are PQ are similar things of different kinds. What does that mean? That means again the previous question you saw, na, that 5 oranges, 4 mangoes, right? And 3 bananas. Hai na? So 5 oranges are similar, 4 mangoes are similar, 3 bananas are similar. But these 3 are different kinds also. Hai na? These are not similar. Individually they are similar. Okay. And now n distinct things you are having. So suppose after that you are having, let's say, orange, mango, banana, and you are having, let's say, kiwi and dragon fruit, and then 1 watermelon, individual, one watermelon, and like 1 more fruit, if you can tell me, guava. Okay, so basically 5, 4, 3 and 1, 2, 3, 4. So this is again 4. One more. Now 2 more actually I want, so that we will differentiate between these 2. Kiwi, dragon fruit, watermelon, butter fruit. अरे क्या हो गया? Fruits के नाम ही नहीं याद आ रहे. And then pineapple. हाँ, correct. Okay. Apple. हाँ, अब याद आ रहा है. नहीं, but it's fine. ठीक है. Then the number of ways of selecting at least one thing. So now, again, this many things. So 5 oranges, 6 ways. ठीक है. 5 oranges, 6 ways. So the answer will be P plus 1. ठीक है. 4 mangoes, so 5 ways. Answer will be Q plus 1. Then 3 bananas, so 4 ways. So R plus 1. P plus 1, Q plus 1, R plus 1. It is clear. Here 6, 5 and 4. It is clear. Correct. Now we are having distinct. 1, 2, 3, 4, 5, 6. 6 distinct. Now, kiwi fruit. There are only two ways. Whether to take kiwi or not take kiwi. Because I have only single kiwi. Take it or leave it. 2 ways. Take it or leave it. 2 ways. Take it or leave it. 2 ways, 2 ways, 2 ways, 2 ways. So 2 raised to power 6. So the answer of this question will be 5 plus 1 6, 4 plus 1 5, 3 plus 1 4, 1 2 3 4 5 6, 2 की power 6 minus 1. This will be your answer, and in this case the answer will be again p plus 1, q plus 1, r plus 1, and n distinct is 2 raised to power n minus 1. Okay, if you feel ki arey ma'am what is happening, if you do one question you will be like, oh that was it kya. Chalo, let's do one question on this. ठीक है? In a bookstore there are 4 copies of one book. That means 4 identical things, 5 other identical things, that is 5 copies of another book, and single copy of 5 different books. So that means these 5 books are having only single thing. Now in how many ways a person can purchase at least one book? है ना? At least one. So again 4 plus 1, correct? 5 plus 1, and that's it. Now 5 different books. So 5 different books, B1, B2, B3, B4, B5. Okay. So B1 के लिए, whether I can take it or leave it, 2. Take it, leave it, 2 की power 5. But a minus 1 will ensure that here we are not taking that. So this will have a single case where you have not taken this book, you have not taken that book, you have not taken like any copy of B1, any copy of B2, B3, because take it, leave it na, to leave it wala case, leave it. So there will be a single case that we are subtracting because of at least one keyword. Okay, all right. Chalo, the required number of ways you can clearly see is this. All right. Okay. 959 will be the answer. Okay. So now the same thing which we have already studied, like just now 4 different cases we have studied, right? 4 cases. So in 4 cases there is one application of all these cases, and that is model based on divisors. Suppose I am taking a number which is let's say 2 into 3 into 5 into 7. 7 5s are 35, then is 70, so 210, correct? Correct kya? 5 2s are, yes, 210. Suppose I am taking this, है ना? 200. No. Bad example, है ना? Let's take 2 into 3 square into 5 cube. Yes. So 125 into 2, 250. 250 into 81. Okay. Two 250 जो भी है इसको calculation I'm not doing right now. ठीक है, but this is your number. ठीक है, चलो कर लेते हैं. 125 into 2 is 250. 25 into 3 3 is 9 है ना? हाँ, 25 into 9, correct. So this is going to be 225. 2250. Now it's correct. Yes, है ना? हाँ, तो if 2250 is given to you, right? So what will you do is, first of all 2250 के you will do prime factorization, है ना? So 10, so 2 से कर लो, तो 1, then 1 2 5, then 5 से कर लो, 5 2s are 10 and 5 2s are 10, 225, correct? Then 3 से, so 3 1s are 3, 3 7s are only prime numbers, 3 7s are 21, 3 5s are 15, then again 3 से कर लो, 3 1s are 3, 3 5s are 15, then again 3 से कर लो. अरे 3 क्यूब है क्या? होल्ड ऑन, फिर से करते. What has happened to my calculation these days? हाँ, चलो 2250 है ना? 10 से करते हैं. 225, you know 225 is 15. हाँ, this is better, है ना? तो 15 is what? So this is 3 into 5, 3 into 5. तो हाँ 3 square. This is correct. हाँ correct है ना? ऐसे ही आएगा. चलो So now just tell me that divisors, what are the divisors of this thing? So let us list down all the divisors, okay? So divisor 1 will be the divisor and 2 will be the divisor. Then 3 will be the divisor, correct? And 3 ke baad we have 6 also as a divisor. Then 9 also divisor, okay ma'am. 12 is the divisor, 12, no 12 will not be there. Then 15 will be there, after 12 there will be 15. 15 ke baad 18 will be there, correct? Yes, 18 will be there. 18 ke baad we are having 21, no. 25 will be there. हाँ, 25 के बाद think 27, no. 25, 26, 27, 28, 30. 30 is your 3 into 10. Yes, 30 will be the answer. 30 के बाद 35, no. 40, no. Then 75 directly. ठीक है. 30 के बाद 60 will be the answer. क्या 60 is actually 60 is 2 into 30. Yeah. No, 60 will not be there. Directly 75 shall I write? 75 के बाद you are having 100 will not be there. Okay. And then you will be having 225. है ना? And 2250. So many will be there. I can't be listing them all the them down, but majority. चलो, ठीक है. So 1 is the divisor. 1 means what? 1 means that, so you are having 1, 2. You are having 2, 3. You are having 3, 5. Right? Okay. Now 1 means what? 1 means that you have, so you basically taking, if you talk about this 2, how to like frame the divisor, what is the idea behind the divisor formation? So this 2, now understand it. This 2, you can take it or leave it because 2 is appearing only once. So you can either take it in this your divisor or do not take it. So 1 means you have not taken 2, you have not taken 3, you have not taken 5 as well. Okay. So basically you have not taken any of these. Okay. That is 2 taken 0 times, 3 taken 0 time and 5 taken 0 time. Here 2 is taken 1 time, 3 is taken again 0 time and 5 is taken 0 time. 3 means 0, 1, 0. 2 is taken 0 time, 1 is taken, 3 is taken 1 time and 5 is not taken. Now what about 6? So 6 के लिए 2 taken once, 3 taken once, 5 taken 0. What about 9? So 0, 2, 0. 3 taken twice. What about 15? So 3 5s are 15. 0, 1, 1. 18, what about 18? So 18 is 3 ka square into 2. So 2, 1, 0. Like that. 2250 mein what you are doing, understand? What is 2250? 2250 mein have you taken 2? Yes ma'am, once. Have you taken 3? Yes ma'am. How many times? Twice. And have you taken 5? How many times? 3 times. है ना? That's why 2250 will be 5 cube 3 square 2. Okay. So basically the permutation, and now you understand there is some permutation and combination involved. That how many times you take 2, how many times you take 3, how many, the number of divisors will be number of permutations. That how many times 2 you can take, how many times 3 you can take, how many times 5 you can take, right? Basically 225 is what? That 2 taken 0 time and 3 taken 2 times and 5 taken 2 times, है ना? So yes, number of divisors, how to calculate? So first of all, the very first step is calculate the prime factorization. Okay. Now 2 you are having single 2. So 2 के लिए you have 2 options. Either to take it or leave it. Take or leave. Okay, taking 0 times or taking 1 time. 3 you are having how many options? So 3 की power is 2. So double, two things are there. 2 identical things are there. So 2 identical things can be taken in 3 ways. can be taken in 3 ways. Either you do not take that 3, either you take that 3 once, or you take that 3 twice. So there are 3 options. And 5. 5 can be taken in 4 ways. 4 options. Either not take it, or take it once, take it twice, take it thrice. Okay, the 4 options. 5 3s are 12. 12 2s are 24 will be the answer. Now you must be wondering, ma'am, hold on, it is so heavy. Let me tell you the final formula. So what you need to do is, what is the shortcut? That you have to add 1 to the prime factorization power. So 1 plus 1, ma'am, 2. 2 plus 1, 3. And 3 plus 1, 4. So let me just give you one example, 1350. So suppose 1350 is there. And now 1350, okay, what you need to do is, you need to find out number of divisors. So for that, 1350, okay, you have to figure out the factors. Let's do that. So 10, 135. Then you are having 45 into 3, 3 into 1. So again, so this is 45 is 9 5s are 45. So again, 3 ka square and one more 3, 3 ka cube, correct? Then 5 ka square and then 2. 2, 3 cube, 5 square. Hai na? So number of divisors will be what? So power plus 1. 1 plus 1. 2. 3 plus 1. 4. 2 plus 1. 3. So 2, 4, 3. 2, 4, 3. 2, 4, 3 will be 24. Hai na? 2, 4, 3. Very simple. How to calculate number of divisors? Calculate prime factorization and add 1 to the powers, multiply them, and we are done. Okay. Alright. Clear? Chalo. Alright. Now number of proper divisors. Proper divisors. What is proper divisors? Proper divisors means you have to exclude 1 and the number itself. 1 is not at all proper divisor of any number. So 1 is not proper divisor, and that number 1350, by the way, 1350 is also a divisor of itself. These 24 includes, 24 divisors include 1 also, and it includes 1350 also. So you have to remove these two, so now count will be 22. Hai na? Easy peasy. Till now, okay, chalo. Except 1 and 1350. Correct. Sum of divisors. Now you have to be a little bit intuitive over here. So sum of divisors, let me tell you that, let me just write first what will be the sum, and you will be stunned. Ki ma'am, what did you just do? Sum of divisors may see what is happening. Again, the same logic I am going to apply. 2 ki power 1. So what are the possible things for 2? If you do not take 2 at all, it will be 2 ki power 0. If you take 2 once, it will be 2 ki power 1. Correct? And now 3. Taking 3 will be not take it, taken once, taken twice, taken thrice. Taking 5, taking 0 times, taking 1 time, taking 2 times. Okay. Alright. So this is 2 ki power 0 plus 2 ki power 1. 3 ki power 0, 3 ki power 1, 3 square, 3 cube. Now if you multiply, you will get the sum. Now you will be wondering what, how. Let me show you first. See how many divisors you are seeing here. 1 will be the divisor, 2 will be the divisor, 3 will be the divisor, 5 will be the divisor, 6 will be the divisor. Okay. Then 1350 will also be a divisor, and 1350 will also be divisor. Okay. So what I'm trying to tell you is all these divisors, and there are more also, 24 are there, right? I'm not going to write all the things, but I will show you that this value is 1 plus 2 plus 3 plus 5. Basically in here, I am getting all the how many? 24 divisors. This is actually written as sum of 24 divisors. Let me prove you. Let me give you the proof. Acha, you want 1. So for 1, if you multiply these three, na, so 1 ke liye 2 ki power 0 will get multiplied with 3 ki power 0 will get multiplied with 5 ki power 0. So there will be one term which will be 1. So this you are getting. Now what do you want? 135. Let me just check. 135 is what? Tell me. Ma'am, 135 is 45 into 3. That means 3 ka cube. Okay. And into 5. 3 cube into 5. And now 135 is what? Tell me. 3 cube into 5. Correct? So 3 cube. So now from this bracket, I'll be picking 2 ki power 0. From this bracket, I'll be picking 3 ka cube. This will get multiplied with this. And from this bracket, 5 ki power 1. When these three are getting multiplied together, 135 will get generated. And if you're looking for the last 1350, so you have to multiply 2 ki power 1, 3 ka cube and 5 ka square to get 1350. In this manner, if you just multiply, you will get all the divisors over here. Okay. All right. Clear? Sum of, so this is your sum of divisors basically. Now in here you know that this is a geometric progression of two terms. Let us apply the formula. है ना? What is the formula? So a r की power n minus 1 upon r minus 1. है ना? So a is what? 1. So 1, 2 की power 2 terms. So 2 square minus 1 upon 2 minus 1. Then 4 terms. 3 की power 4 minus 1 upon 3 minus 1. First term is anyway 1. 5 का cube minus 1 upon 5 minus 1. ठीक है? Sum of divisors. So the answer will be 133720. Clear? Okay. And now if somebody asks you what is sum of proper divisor. Sum of proper divisor. Okay. So sum of proper divisor will be 3720 and you have to subtract 1 and 1350. है ना? Because 1 and 1350 are two divisors which are not proper divisors, which are improper divisors basically. Okay. All right. Clear? All right. Now we'll be actually jumping on to geometry models. So let's do some problems on geometry models. So geometry models may first understand the types, the categories, and then jump onto the problems, right? Let's understand the models basically. So in geometry models, okay. So let us talk about few standard set of problems or problem statements. There are n points in a plane and no 3 are collinear. Okay. So n all are non-collinear points. Okay. So basically collinearity to you know, like see 2 points. If I make 2 points are always collinear, right? 2 points, these 2 points are always collinear. Okay. So that's why they always talk about 3 points. We will never talk about collinearity of 2 points. Okay. So now if third position is like this, then all 3 are collinear. If third point position is this, then 1, 2, 3, these 3 are non-collinear points, right? Okay. So yeah. So let me just tell you one thing, that if there are like 3 collinear points, how many lines you can draw from these 3 points? Single line, right? And whenever there are 3 non-collinear points, then you can draw 1, 2 and 3 lines out of them. So there is a difference. When there are collinear points, the number of lines will be 1. Okay. And when there are non-collinear points, the number of lines will be more. That depends on how many collinear points are there. Okay. So basic concept, this concept is we'll be using in this particular problem. So there are n points and no 3 of them are collinear. Now how many straight lines you can form? So if no points are collinear, then NC2 straight lines will be formed. So basically, if there are like suppose 1, 2, 3, 4, 5 points are there. Now every selection of 2 points, right? 1, 2, 3, 4, 5, right? It's just the same as handshake problem. Every 2 unique selection of points or every selection of 2 unique points will give me a straight line. So if I select 1, 2, there will be one straight line, 1, 2. Then 2, 3, then 3, 1, right? Then 3, 4 and 4, 5, 4, 1 also, okay, and 1, 5. So many, right? So how many that will be for 5 points? We have 5C2. 5C2 means how many lines? So this is 10 lines, NC2 straight lines, right? Okay. So NC2, this is a general formula. But how many triangles are possible? So how to form a triangle? Every 3 unique selection, every Unique selection of 3 points will give you a triangle. So NC 3 triangles, right? So simple thing, simple over here. But understand, n points, no 3 are collinear, okay? But now we can add some twist to it. We can make some of the points collinear, okay? Chalo. So there are n points in a plane, out of which m points are collinear. So suppose the question will be, there are 10 points in a plane, out of which 4 are collinear. So the point is basically 10 points versus 6. 4 are collinear, 1, 2, 3, 4. So these are the 4 points. And non-collinear points, there is a way of representing non-collinear points on a circle, right? So 1, 2, 3, 4, 5, 6. That's it. That's it. Okay. 1, 2, 3, 4. So 6 and 4. Correct? 6 and 4. So there are n points in a plane of which m points are collinear. Then by joining them, we can obtain how many? So understand what will happen over here. So if there are 10 points, so usually ideally 10C3 triangles will get formed. Or if I just talk about, let's forget about the triangles. Let's talk about the lines first. Hai na? So if ideal case, if no 3 are collinear, so 10C2 as per the formula. But actually using these 4 points, understand, using these 4 points, there will be only one line. But we have counted those lines in here, extra lines, because using these 4 points, there will be only one line. But here I have counted so many lines using these 4 points. So we have to subtract. So minus 4C2. 4C2 means we are subtracting all the lines which we have miscalculated using these 4 points, right? So selection of 2 points out of these 4 will give me total number of straight lines which we have created from this, which is included in 10C2. We are subtracting it, but see, what did I do? I actually subtracted everything. So I have to add plus 1, because one line to I am creating now. One to we should count it 1, okay? So using these 4 points, there is only one line, but we have counted so many lines. So that we have removed, but we have to add 1. So finally the answer will be, if you see, NC2 minus MC2. M are collinear, right? So here 4 are collinear, that's why 4C2. And plus 1, you have to add 1, because 1 to is there now. You have to count them 1. So NC2 minus MC2 plus 1 straight lines. Now what about triangles? Again same thing. So NC3, right? NC3, but using those M collinear points, you have calculated extra triangles. Okay, so if I just tell me, using the collinear points now, how many triangles will you be able to form? Tell me. 0, right? Collinear points say there is no such triangle, 0, and you have counted it in NC3 or 10C3, you will say. So minus MC3, that's it. No need to add plus 1, because using collinear points, we can form one line, but we can form 0 triangle, right? That's why. So it is NC3 minus MC3. Now geometry models. Geometry models, okay? Now geometry models will have a different question, different problem statement. It is a question of polygon. So number of diagonals of a polygon of n sides, okay? So what is happening? N sides, polygon, right? How to form a polygon? So let me just tell you. Suppose you are here to form a hexagon, right? Hexagon looks like this. Circle pe hexagon, okay? So circle pe you have to take 1, 2, 3, 4, 5, 6. So this is your hexagon, right? Now diagonals. So this will be your diagonal, this will be your diagonal, this will be your diagonal, right? So basically 1, 2, 3, 4, 5, 6. Using these 6 points, first of all, tell me how many 6. These 6 are, by the way, non-collinear, right? So using this point, how many lines we can draw? Ma'am, 6C2. But this 6C2 will have all the lines, diagonals plus sides, diagonals plus sides, okay? We are only looking for the diagonals, right? Number of diagonals. So why can't we just exclude the sides. So there will be 6 sides. So if I just remove the 6 sides, then remaining will be what? So remaining will be only the diagonals. So now you know that number of diagonals will be what? NC2 minus N. Okay. So NC2 means total number of lines, including sides and diagonal, right? And N will be your number of sides, which you do not want to include. So NC2 minus N. If you open it, you will get N minus 3 by 2. Okay, NC2 minus N. Perfect. Clear? Okay. All right. Now parallelogram. Suppose there are m parallel lines of one kind and n parallel line of another kind. How many parallelograms you can form? So just understand that how do you form a parallelogram. To form a parallelogram, you actually need four sides. To one kind of parallel, to another kind of parallel. That's it, 4 lines. So set of m parallel lines are intersected by another set of n parallel lines. So basically, out of these m, you need 2, and out of these n, you need 2 more. So MC2 multiply NC2. Okay, this will be the answer. MC2. Okay, so MC2 say you have selected these 2 lines. NC2 say you have selected these 2 lines. So can you see a parallelogram is formed, right? Okay. So every unique selection of this will give you a different unique parallelogram every time. Okay, all right. Now, number of intersection of 2 different figures. So number of intersection of straight lines, number of intersection of circles, number of intersection of a straight line and circle. Okay. So the maximum number of point of intersection of n straight lines in a plane is, if there are n straight lines, okay, if there are n straight lines, so now just tell me, if they are parallel, then they will not intersect. But if they are non-parallel, then they will definitely intersect, and we are looking for maximum number. That means it's in our control that how we want those 2 lines to become. We will never want all those lines to be parallel because we want point of intersection, right? So every unique selection of 2 lines gives me single point of intersection. So yes, that's why NC2 will be maximum of point of intersection of a straight line. Okay, so answer will be NC2. N straight lines in a plane. So every 2 selection of lines, like every 2 lines will give single intersection point, right? Now n circles are in the plane. So again, the position of circles can vary. The position of 2 circles can be, they both are like not at all intersecting each other, right? Both circles are touching each other. And both circles are intersecting each other at 2 points. Okay, that's it. There are 3 cases only, right? Okay, so we want maximum intersection, so we will prefer this diagram. So now understand, every 2 circle is giving me 2 points of intersection. So n circles may, if I select 2 circles, so NC2, and 2 circles giving me how many? 2 point of intersection, so that is multiply by 2, right? So this is NC2 will give you how many unique pair of circles you can select, how many unique pair of circles you can select, and the moment you have selected 2 circles, point of intersection will be multiplied by 2 because we are getting 2 intersection points over here. Okay, chalo. Now I guess we have understood everything in this. We can do one thing now. We can start solving problems. There are 12 points in a plane. In a plane, 12 points in a plane, right? Of which 7 are collinear. By joining them, we can have how many number of straight lines and how many number of triangles, correct? So how many number of straight lines? We do have a formula. 12C2 से सबसे पहले all the straight lines we have calculated minus 7 are collinear. So we will subtract all those lines because 7C, like out of these 7 lines, understand 12. Now, so 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. Correct? So using these 5 points, these 7 points, I will not be able to generate so many lines. In fact, I'll be able to generate only one line, right? So minus, subtracting all those lines which we have miscalculated, yeah, extra added by this 12C2, minus 7C2 plus 1 will be the answer, right? So 12C2 minus 7C2 plus 1. And similarly, if I talk about number of triangles, so that is going to be 12C3 minus 7C3. Perfect, because there will be no triangle by these 7 lines. So no need to add, just subtract. Okay. All right. Clear? Chalo. 185 will be the answer. Now next question. Again, now you have got the formula, right? A convex polygon has 44 diagonal. Find the number of its sides. Oh, okay. All right. So this is a very good question, I could say. Indirect question. So we know that number of sides, let's say n. So now NC2 will be all possible lines. This NC2 will include sides and diagonals, right? But we only have diagonals. So minus n. Now this will have number of diagonals. This will be 44. So if you solve it, n minus 1 by 2 minus n equals to 44. Okay? N minus 1 upon 2 minus 1 is equals to 44. N minus 3 upon 2 is equals to 44. N minus 3 is equals to 88, or we can say 11 into 8. So if n is 11, n minus 3 is 88. This is the final answer. N is 11, right? Okay. Clear? Perfect. N is 11. Next question on our screen. The number of parallelograms that can be formed from a set of 4 parallel lines intersecting another set of 3 parallel lines. So 4C2 into 3C2, right? 4C2 into 3C2 will be the answer. So basically 1, 2, 3, 4 and 1, 2, 3. 1, 2, 3, 4. Okay? So now number of parallelograms that can be formed from a set of 4 parallel lines. So this is 4C2, 3C2. This will be your final answer. Easy peasy, right? Okay. Now, so we are done with geometry models. Okay. Now we will talk about principle of inclusion and exclusion. Okay. So sometimes what happens is, this we have actually done some work on this. So suppose, okay. All right. Let me put it this way. So suppose you have, all right. So suppose you have some numbers, let me just tell you. And numbers are even numbers starting with 2. 2, 4, 6, 8 and 10. 5 even numbers, there are 5 multiples of 2 also we can say. And 5 multiple of 3. 3, 6, 9, 12, 15. Okay. Now I just want you to, I just want you to tell me the total number. What is the total? So total can be 5 plus 5, because I am telling you, basically there is a set of numbers which is having first 5 even natural numbers, okay, and the first 5 again multiple of 3, natural number but multiple of 3. Okay, now what is the total number? So you'll be like, okay ma'am, 5 plus 5. But wait a minute. Can you see the 6 is coming in both the sets? That means 6 I have counted here also. 6 I have counted here also. Oh. So we have to, because 6 we have counted how many times? Twice. So we have to subtract once. So minus 1. So basically, what we are doing is, we are doing the set theory method only. Set theory says that suppose you are having set A and you are having set B, and you want to calculate the number of elements of set A or B, that is A union B you want to calculate. So A union B, so you know that A union B will be cardinality of A plus cardinality of B, minus you have to make sure that you are removing the common element which is counted here and here. So you have counted it twice, so you have to subtract it once, because one time to you want, no? Like one time to you want, you don't want to like erase it. You wanted this portion to be counted at once, just like this. 6 we needed to count. It's not the case that we want to remove 6 from everywhere. No. We want to have 6 but only once. By mistake, because we have counted it twice, na, that's why we are doing -1. We are not doing -2. Okay. Because we have counted it 2, so -2. No. So that's how it is, right? So let's do one question and then understand. Find the number of words that can be made by permutating all the letters of the word Roorkee, which neither begins with R nor end with E. Okay. Now neither nor. So what we will do in this question is, okay, neither nor. So basically they are talking about neither nor. So neither A nor B is total minus A union B. So basically what we are going to do is, we are going to find out the total number. Yes. So total number, tell me, total number Roorkee. So ma'am, 1, 2, 3, 4, 5, 6, 7. 7 factorial, because it has 2R, so 2 factorial, 2E, 2 factorial, and 2 double E, that's why 2 double O, right? Double R, double O, double E. So total minus, what we are going to do is, we are going to write down A union B. Now what is A? A is that thing where word starts with A, right? So A is that set where the word begins with R. B is that set where it ends with E. Ends with E. And A intersection B will be that thing where it starts with R and end with E. Understand? Okay. So we are first of all talking about, let's count those words which is either having R in the beginning or having E in the end. Right? So let us fix ki R is in the beginning. Now how many 7 are there? So 6 factorial upon 2 factorial, 2 factorial. Okay? So 720 by 4. 720 by 4. Now E will be in the end. So suppose if I fix E in the end, again it is going to be 6 factorial by 2 factorial, 2 factorial. So this is 720 by 4. Okay. Alright. Clear. And now, see, understand what is happening. So I have said ki acha R is fixed over here. So all the words will start with R. So there are this many words. Now just tell me, don't you think in this there will be some words which will end with E as well? So that means we have unknowingly, because we were focusing on R, but all the words starting with R, but there will be some words which will be ending with E as well. Okay. And here what did we do? We just focused on E, ends with E. So there will be some words in this which will be beginning from R. Okay. So basically we have counted all those words which starts with R and at the same time ends with E. So here also I have counted it. Here also I have counted it. Okay. So we need to subtract it. A intersection B, that means R and E. Now tell me. So it is going to be 5 factorial upon 2 factorial. So this is going to be 120 by 2, so 60. Right? So this is going to be minus 720 by 4 will be 180. Correct? So this is 180 plus 180 minus 60. Right? 7 factorial by 8. So 7 factorial, so 7 into 720 by 8 minus 180, 180, 360 minus 60. 8 9s are 9 7s are 63. 630 minus 300. So this is going to be 330 as your final answer. Yes, tell me. Clear? 330 will be your final answer. Let me just show you. That's how it is done. Okay. So total minus all the words which either starts with R or ends with E. Okay. All right. Clear. Okay. Now we are having last two topics of permutation and combination, derangements and Beggar's method. Okay. So let's do it one by one. All right. Let's focus on derangements. Okay. Derangements. If n things are arranged in a row, then the number of rearrangements such that none of them occupy their original position is called derangement. So derangement is nothing but, so suppose we can do one thing, one exercise. Suppose we are calling out 5 couples. 5 couple means 10 people, right? 5 couple means every couple is having one husband and one wife. Okay? So husband, wife, 2 people, husband, wife, 2 people, husband, wife, 2 people, husband, wife, 2 people, husband, wife, 2 people. Total 5 couple. That means total 10 people, out of which 5 are men, 5 are women. Okay? All right. So just understand. This is husband, this is wife. Husband and wife belong to each other. H1, W1. Then we are having H2, W2. Okay, let's keep it 3. Hai na? For simplicity, H3, W3. Now, these two are belonging to each other, right? Husband and wife. These two are also belong. They have come together. These two are also together. Now we have to dearrange them in such a way that husband and wife, all the husbands and all the wives get separated. So, how many ways we can do that? So, basically, H1, wife 2. Okay, H1 and wife 2 we can do. H2 and wife 3. And H3 and wife 1. This is one way. Hai na? One way of dearranging 3 couple. 3 things basically. Okay, one way of dearranging, right? So basically we call it as D3. D3. Okay. So number of dearrangement of n distinct things can be denoted by Dn, right? So it is having basically, so this is one of the cases. It can be possible that we have an example of, like, let's see, yes, lock and key. So understand what is happening, lock and key. So L1, key 1. Then L2, key 2. L3, key 3. Okay, so we need to make sure that none of them occupy their original position. None. None at all. Okay, so this is denoted by Dn. Clear? So the formula, there is direct formula. Formula says Dn is equals to n factorial 1 minus 1 upon 1 factorial plus 1 upon 2 factorial and so on, right? So this is the formula. Let me just show you. So again, find the number of derangement of the letters of the word bag. So suppose B is having first position, A second and G third position. So basically they are talking about D3. So formula is 3 factorial. Now understand the formula. 1, it starts with 1, minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial. That's it. You have to stop it till here. Now 1 minus 1 is cancelled out. So this is 3 factorial is what? 6. 1 by 2 minus 1 by 6. Multiply. So 3 minus 1, so 2. So D3 will be 2. D3 is coming out as 2. So there are 2 ways to go about it. Okay. 2 ways to find out the number of dearrangements. Okay. Now, just like I told you, D3. So D3 is 2. So there are some standard results. Let me tell you. D2, if you apply the formula, it is 1. D2 is coming as 1, obviously. Okay. So suppose we are having 2 things, 1, 2 and 1, 2. Okay. These are the positions. You want dearrangement. So there is only one way. Just keep this 1 with 2, keep this 2 with 1. Okay. All right. So we are dearranging. We are just refraining things to go to their original position. So D2 is 1, D3 so we have just calculated, it is 2, D4 is 9, D5 is 44 and D6 is 265. That if you learn this now, your life will be much easier. Otherwise, the formula is very easy. It is not very difficult to calculate also, but this will give you some confidence as well that we know the values. Okay. Otherwise, you do have a formula as well. Okay, chalo, let's do one question. The number of ways in which all the letters of the word chair can be arranged such that no letter is in its original position is. No letter is in original position. Okay. No letter is in its original position. All right. Okay. Cool. No letter is in original position. Okay. So D4 we are talking about, sorry, 1, 2, 3, 4, 5. So D5. D5 we know, ma'am, 44 is the answer. Right? Easy peasy. है ना? ठीक है, तो D5 is the correct answer. Now, understand, there is some twist to it. Maybe there is some twisted questions. 5 balls of different color, 5 boxes of same as these of balls. So basically, what is happening? I have a blue ball and a blue box. I have a white ball, white box. Gray ball, gray box, black ball, black box, red ball, red box. So 5 different boxes, 5 different colors, and each ball have its own box. The number of ways in which the balls can be placed such that no ball goes to box of its own color. Again, they are talking about D5, very easy, 44 is the answer. They are talking about de-arrangement of all 5 objects. Easy, 44. Okay, chalo. Now, let's do some twist because now I know what the de-arrangement is. Let's do with some twist. 6 letters are numbered with 1, 2, 3, 4, 5, 6 written on them are put into 6 envelopes with number 1, 2, 3, 4, 5, 6, 7 written on them too. So basically, every letter is having its own envelope, right? No letter is in its correct envelope, है ना? So now we have to put in such a way that no letter goes to its original envelope. So that is D6 clearly, and we know that the value of D6 is what? 265, right? 265 is the answer. First case is sorted, 265. Now second onwards, be very careful and you have to apply your brains. Okay, it is like your brain. Okay, I can't help it. Okay, okay, these are the type of problem when you have to think. I will help you in thinking for the very first time, but after that you have to develop your thinking skills. Okay, at least one letter is in its correct envelope. Okay, all right. So what they are saying is at least one letter. At least one means what? That at least one means, I have already told you, at least one is equals to total ways minus no letter goes into its correct envelope. No letter goes into correct envelope. So basically, at least one means total minus none. Okay? At least one means total minus none. What are the total ways? Including everything, including arrangement, dearrangement, everything. Like goes into right position, goes into not right position. So this is basically total ways will be 6 factorial. Okay? Minus we want no letter goes into correct envelope. So no letter goes into correct envelope, 265. So 720 minus 265, 10 minus 5, 71 minus 26. 71 minus 26. 555. 455. Sorry, 455. This will be the answer. Okay? 455. Done, done, done. At most 2 letters are not in their correct envelopes. Okay. At most 2 are not in their correct envelope. That means maximum 2 should not be there in their correct envelope. So maximum 2 means third will be, what they are saying is that they are fine if all are on their place. And a maximum 2 means what? 0 letters are not in their correct envelope. That means all the letters are in their own place plus. Okay. 1 letter is not in its exactly. It is actually, I am talking about exact thing. Exactly. Or exactly all are on their correct place. 1 letter is not in its place, and plus 2 letters are not in there. Okay. Now all the letters are in their correct place will be 1 plus 1 letter is not in its place. Can this be possible? Exactly 1 letter. So we have 6. So if I just think that first letter, I can make sure that first letter will go into like maybe the 5th envelope. Then automatically I have to 5th letter should go into the first envelope, right? If I am making sure that first letter going into 5th, any random thing, so I am just thinking that first letter should not go into first. First letter will go into 5th wala. So if first is going into 5th, then what will happen with 5th? 5th will go into some another. So this is not possible, ki 1 letter I will be misplaced, and so at least everything will be disturbed, right? It happens. If a student takes your place, go and takes your place, then what will you do? Automatically you will get disturbed. So exactly one person is getting disturbed, not possible. Minimum 2 to will get affected. So that's why this is not possible. Plus, now 2 letters are not in their place. 2 letters are not in their place. So first of all, let us select those 2 letters. Okay. So 6C2. So I have selected those 2 letters which we am going to disturb, dearrange, and rest 4, let's keep it sorted. So rest 4 will go into their own places by one way. Just go. 2, 4, 3, 3, 4, 4, 5, 5, 6, 6. Now dearrangement of 2 letters will be what? Done by 1. So answer will be what? 62. So this is going to be 15 plus 1, 16. 16, correct? 16. Third and fourth, exactly 3 letters are not in their correct envelopes. Exactly 3. So yes, first wala to we have done. No letter in correct position. D6 is 265. And second is at least 1 letter. So total minus this 6 factors 455. This we have already done. Now third we just do. At most 2 letters not in their correct envelope. So all letters are in correct envelope plus exactly 1 letter plus exactly 2 letters. Now all letters are in correct envelope 1. This will be 0 and this will be 62 into D2. So 62 is 15, D2 is what? 1. So yes, 15 plus 1 will be 16. Now fourth, wherein exactly 3 letters are not in their correct envelope. So 3 letters, so 63, let us pick those 3 letters which we are not willing to put in the correct envelope, and now remaining 3 are sorted by one way. Just put 4, 4, 5, 5, 6, 6. Now 1, 2, 3, suppose you have selected. So those 3 can be dearranged by D3. So D3 is, 9. 9? No. D3 is 5. 5 kya? D3 is 2. D3 is 2. Oh yes. D3 is 2. D3 is 2. So this is 20 into 2. 40. Derangement done. So now we have to understand the Beggar's method, okay? So first of all, the statement of Beggar's method, let us understand that first, okay? And then talk about that what exactly is Beggar's method, okay? So suppose you have to distribution of n identical things things, n identical things, okay, distribution of n identical things among r persons when each person can have none, one or more. Understand what is this statement trying to say? Okay. So what we are doing is we are having n coins, rather n coins. Okay, things ko hata ke coins, है ना? Now coins. Why? That's why because we have like created a scenario where coins are involved. So n identical coins are there. So that's why beggar's method. Okay. So r persons nahi hai. So it is a beggar. N identical coins should be distributed to r beggars. So suppose you have like, let's say 8 coins. Okay. Suppose you are having 8 coins and you are having 4 beggars. Okay. So the condition is you have 8 identical coins, maybe 1 rupee coin. Okay. So 8 1 rupee coins should be distributed to 4 beggars, wherein the agenda is to just exhaust all the 8 coins. I am not bothered whether each beggar is getting at least once or each beggar, so it should be distributed evenly. No. Okay. So suppose 4 beggars are here. I have 8 coins. If my will, I can give all the 8 coins to beggar number 1 and rest 3. So that's why each beggar can have, among our beggar, when each beggar can have none, one or more. Okay. So basically any beggar can have 0 coins. Okay. And any beggar can have 1 coin also. Any beggar can have more coins also. Okay. So multiple cases are involved over here. So how will we tackle it? So first of all, 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is a brilliant method to distribute it. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Right. So now in this method, what we do, so this is a technique. You have to understand that by this technique, we are actually able to distribute 8 coins in such a way. Okay. So now there are 4 beggars, right? So just understand what we will do is always think about subtracting 1 from the number of beggars. Okay. So here 4 beggars are here. So 3, we will get 3. So what is 3? So here we are going to add r minus 1 false coins in this 8 coins. Hold on. Let me tell you one more time. What are we trying to do is we are actually adding 3 false coins over here. Okay. 3. Why 3? Because always add r minus 1 false coins in this. Now what is false coins? False coins, or you can say partition coins. Okay. Alright. So partition coins. Suppose if I just keep my first coin over here, second coin over here, I can place it anywhere. Third coin over here. Yes. Third coin over here. Okay. So what is happening if I just pick these third coins? Okay. So basically these coins are just creating the partition in such a way that first partition P1, partition number 2 P2 and partition number 3 P3 will be here. Now can you see the 8 coins are divided into section number 1, section number 2, section number 3, section number 4. So in this manner, always whenever there are 3 partition coins, always there will be like one more region. If you add 2 coins, okay? If you add 2 coins, there will be 3 regions. So you have added 3 partition coins. Always there will be 4 regions. Now just tell me, beggar number 1 will get how many coins? Beggar 1 gets 3 coins. Beggar 2 gets 2 coins. Beggar 3 gets 3 coins. And beggar 4 gets 1 coins. Okay. Alright. So now, okay, all right. But ma'am, will it cover all the cases? So basically you are saying that beggar can get all the coins as well, none, one or more. So let me tell you. 8 coins are here. Now next time what I will do is I will add 3 coins in such a way that first coin lies over here, second and third here. That's it. Okay, there are multiple ways. I am just taking different cases and showing it to you. Okay, so this is partition number 1. That means first beggar getting 2 coins. Partition number 2, second beggar getting only 1 coin. Third beggar will get 0 coins. Why? Because there is like no coins in between these two partition. And fourth beggar will be having 5 coins. Okay, so the distribution is 2, 1, 0 and 5. This is also one of the distribution. 4 beggars are there. Okay, so this is the distribution. So there are multiple distributions like this. I hope that this is clear. Okay, perfect, right? So now, but what is the answer, ma'am? Okay, we got the technique that this is working out, but how to like get the answer? So what we are doing is actually, if I talk about like adding 3 partition coins, so there are actually total 8 plus 3 total things. Okay, where 8 are for first type identical, like 8 are identical coins and these 3 are other identical. So basically 11 things are there which can be arranged in a line in such a way that 8 are identical and 3 are other identical. So this is 8 factorial, 3 factorial. If you focus on it, actually it is what? 11C3, right? And if I just write 8 plus 3C3, correct? What is 8? 8 is n. Trying to get the formula, right? So n plus r minus 1 cr minus 1. In this case, will it work? So n is 8, r is 4. Just put the formula n plus r minus 1 because we have added 3 coins. So 8 plus 3c3. Okay. Alright. So distribution of alike objects is done by this. Alright. So I guess yes. Let's do one question on it. In how many ways 5 identical balls can be distributed into 3 distinct boxes? So here, these are 5 identical coins actually, and 3 distinct boxes means 3 beggars are there. Beggars will always be distinct, right? That no box remains empty. Now this is something different condition. This condition is a different condition. Okay, no box remains empty. So beggar's method to say ki no, the formula gives you that answer wherein the box, that means beggars, can remain empty. That means they do not get any coins. Okay, so 5 balls and 3 beggars are there. 1, 2, 3 beggar, beggar 1, beggar 2, beggar 3, or box 1, box 2, box 3, and 5 coins are there. 5 balls. Okay, so that means the initial condition is that you have to at least keep 1, 1, 1 balls in each box. So what will I do is, let us do one thing. Because balls are anyway identical. So by one way, there is only one way to do it. Just take out 3 identical balls and give it to all the 3 distinct boxes by one way. Okay, so 5 balls minus 3 balls, because we don't want to keep any ball empty. So bare minimum it will be done. That 3 boxes, 3 balls are here. So now you are having 2 balls and 3 boxes. So basically the question turns out to be, you have 2 coins identical, balls are identical, 2 coins to be distributed in 3 beggars in such a way that any box can get any number of balls. So now 2 and 3 and apply the formula. So here n is equals to 2 and r is equals to 3. So n plus r minus 1, cr minus 1. So n 2 plus 2c2, 4c2. 4C2 will be the final answer, right? Because once one ball is done, now then these two balls you can give it to this thing or this thing or this thing, or you can just distribute, right? You don't have to worry about like this box will remain empty kya, right? So this is how it is done. Next. So yes, now the application part, because I have given you a simple question. Application part is number of ways of distributing 10 identical coins among 3 beggars, right? 10 identical coins among 3 beggars. So that again, beggar theorem, n plus r minus 1, c r minus 1, n is 10 and r is 3 directly. Now the application part, whenever you are here to figure out the non-negative integral solution of this equation, these type of equation will be there, okay, wherein x1 plus x2 plus x3 is 10 and they will try to get the non-negative integral solution. What is non-negative? Basically, x1 can be 0 and it can be positive, x2 can be 0 and it can be positive, x3 can be 0, it can be positive. Now think about it. We are distributing 10 identical things actually. 10 things we are distributing to 3 beggars. Same thing now. Such that any beggar can have none, one or more. So it can be possible 0, 0, 10 is one of the answers. Right? 0, 0, 10 is one of the answers. So what we have done over here is these 3 will act as a 3 different beggars. x1 is a beggar standing, that give me something. Okay, you're giving me 0. x2 is again giving me 0 and x3. Sum total should be 10. Okay. So this result majorly applied in finding non-negative integral solution of equations. Okay. So now you have understood this type of problem. So let's start doing it. Chalo, let's start. Find the number of integral solutions of first A. Okay, ma'am, integral solution. So again, 3 beggars, 10, and the condition is non-negative. That means again that x, y, z can have none, one or more. So it is going to be 10 plus 2, right? N plus r minus 1. R is 3, na? So 10 plus 2, C2. So the final answer, let me reveal. Final answer will be what? Yes, this is the formula. So 10 plus 2, C2 is 12, C2. If you solve it, you will get 66. Easy peasy. Right? Now, again, because some twist will be there. Next will be that find the number of integral solutions of this when x is greater than or equals to 1, y is greater than or equals to 0. Okay, now this is something very different. What they are saying is this beggar number 1 should get at least 1 coin. Okay, so again, the same logic I'm going to apply, that no box remains empty. So what will I do? I will give that one thing to that x. So this x, because it cannot be empty, I will give 1 coin to this beggar. So now let me give 1 coin to this beggar. So this is satisfied. X plus y plus z is equals to 9. So I have removed 1 coin, given it in the first place. Now I don't have to worry. Now everything, capital X will be, now if I don't give it to this beggar, it will not be problem because it is already having 1. I have already given 1 to it. Y greater than or equals to 0, Z greater than or equals to 0. Right, again, 9 plus 3 minus 1, C3 minus 1. So it is going to be 11, C2. Perfecto. Perfecto. Okay. So, and C. So this is B part. And what about C part? X plus y plus z is 10. So now again, now you have to give 2 to this. So it is going to become capital X, 2 given already, and 1 to this. So 10 minus 3 coins at least wala given. So 7, right? 7 plus 2, C2. 9, C2. 36. B and C done nicely. Tell me. Okay. So this is B, 11C2, right? And this is C, 9C2. Perfect. Now this. Okay. Number of integral solution of this. Now can you tell me x is greater than or equals to minus 2. Minus 2. Okay. So basically, this is already having, this beggar is already having 2 coins, I can say. So because every time whenever, just for example, y greater than or equals to 1. So we put 1 to this. But now we can get 2 from this. So again, yes, it is going to become capital X plus y, plus capital Y plus Z will remain as it is. Now 10. 1 you are giving it to this y. है ना? Y greater than or equal, at least 1 should be given to y. So it will become 9 and 2 you can take from x. Right? So minus 10 minus 1 but plus 2. So 10 minus 1 plus 2 will be 11. Now it is 11 plus 2 C2. Easy peasy. 13 C2. Clear? So this is your solution. Fine. Hold on. Hold on. So it is oops, I actually z greater than or equal to 0 they are writing, but here they are writing greater than 0. Okay. So this solution, okay, now so this is right. This is absolutely right. Now there is D ka part 2. If they will say x plus y plus z equals to 10 and x greater than minus 2, y greater than or equal to 1, z is strictly greater than 0. Then, just tell me, strictly greater than 0, that means what? Integral solution they are talking about now. So z cannot be 0. That means z minimum has to be 1. That means this condition says that z greater than or equals to 1. So now what you are doing is you are actually giving 1 to y, minimum, bare minimum 1 should be at least 1, and 1 to z, and you are taking out 2 from x. 2 you are giving, 1 plus 1 2, and 2 you are taking out. So basically x plus y plus z, it is becoming balanced. So again 10 plus 2 C2, so 12 C2. This is what has been done in this solution. Okay. All right. Clear? Any doubts? Any confusion? All right. Another question. Now this is the last question. Last question. Let me check. Last question. Yeah. So this is the last question. Okay. Find the number of integral solutions of x plus y plus z is 10. Now, x is lying between 1 to 3 and y and z both greater than or equal to 0. So, here the condition is on x. So, what we can do is x is greater than or equal to 1 and x is less than or equal to 3. So, what we can do is, because there are only like 3 values possible for x, 1, 2 and 3. So, we can take 3 cases when x is 1. When x is 1, y plus z becomes what? 9. So, it is going to be 9 plus 1 C1. So, 10 C1. 10 C1. Alright. Okay. So, 10 for x equals to 1. Now, for x equals to 2 again. So, it means y plus z becomes what? 10 minus 2, 8. So, again, 8 coins, 2 beggars. 8 plus 1 C1. So, 9 C1. Similarly, x equals to 3. The moment you put 3, y plus z becomes 7. 7 plus 1 C1, 8 C1, 8. 9 and 10. All right. Yes. 10, 9 and 8. Clear? Yes. Any doubts? Any confusion? So yes, finally 10 plus 8 plus final answer will be what? 10 plus 9 plus 8, that is going to be 27. 27 is the correct answer. Okay. So I guess we are done with the beggars method as well, and this brings to the end of the permutation and combination session number 2. I hope that you have enjoyed today's session, and I'm going to meet you in the next session. Also, there is a link given in the description box for MVSAT. Okay, I highly recommend that you guys check out MVSAT MVSAT is scholarship test. Vedantu scholarship test. It is happening both online and offline. I will highly recommend go for offline, right? Because you guys are obviously always in online mode these days. Meet some people, right? So MVSAT offline is happening by the end of the September. You can check out the details. Link is given in description box. And if in case you're not able to you're not able to attend or give the scholarship test in offline mode, you can go for online mode as well. It is happening in the beginning of the October. Okay, dates you can check in the description box. This is me, Namrata, signing off. I'll see you all in next video.